Hello everyone, in this video I'm going to show you how you can create smooth motions with the help of Time.deltaTime and Mathf.Lerp function. So let's get started. Here I have very simple scene in which I have just one ball. I have downloaded it from the Sketchfab website, and this is my favorite website to download any kind of model. I have given the link to this ball in the description. You can download from there. So what we are wanting here to achieve from this ball is to rotate this ball along the x-axis and y-axis, and that rotation must be very smooth. And along with that effect, we want to have a very cool damping effect. That means when we release our keys, this ball will gradually stops, and this is called the damping effect. To do that, we would require something related to the time and something related to the interpolation. With the help of this kind of thing, we can interpolate from the previous rotation speed to the final rotation speed over the time. So this is what we want to achieve. So let's create a script and name it Smooth Rotations. Let's open it up in the Visual Studio. So here we have to first of all clear all these things. So we have to create some variables which will be visible in the inspector. With the help of these variables, we can modify our configuration, or we can tune our rotations with the help of those variables. So let's create the first variable, which will be the max rotation speed, which will be 180 degrees per second. And then we have to also create a variable which will be responsible how fast our ball will pick up the max rotation speed. So pick up a speed, let's 4, and the second variable must be how our ball will stop when we release the key, how much fast the ball will stop when we have released the keys. So that will call the damping speed. It's also 4. So we have to create some more variables to hold the result of the current speed. So let's create private float rotation along x-axis, and this will be rotation speed, right? And then create rotation speed along y-axis. And now let's create update method, right? So here we have to write our actual code. So let's transform.rotation multiplied by Quaternion.AngleAxis. So we have to mention here the angle by which we have to rotate, and that angle will be rotation speed along x-axis multiplied by Time.deltaTime. And then we have to specify the axis along which we have to rotate it. So this is vector 3.right. And note that this transform will rotate along their local right axis. So we have to transform it from the local space to the world space. To do that, we have to call some function transform.InverseTransformDirection, right? And then we have to do the same for the y-axis also. Quaternion.AngleAxis rotation speed along y-axis multiplied by Time.deltaTime transform.InverseTransformDirection vector 3 dot down. Okay, so now we have to modify our speed variables, because these are the variables which will be responsible for the speed along any kind of axis in between the gameplay, right? So let's write if input dot get key code dot left arrow. Then we have to change our rotation speed along x-axis. Rotation speed, along x-axis equals to Mathf.Lerp from the rotation speed along x-axis to the max rotation speed time.deltaTime multiplied by the pickup speed, right? Likewise, if input dot get key code dot right arrow, and then we have to change this rotation along x-axis Mathf.Lerp from the rotation speed along x-axis to the negative of max rotation speed time.deltaTime multiplied by pickup speed, right? And likewise we have to do this for y-axis also. Get key code dot up arrow, then rotation speed along the y-axis equals to Mathf.Lerp from the rotation speed along the y-axis to the max rotation speed and time.deltaTime pickup speed. And likewise we have to do this for the down button, down arrow, rotation speed along the y-axis Mathf.Lerp rotation speed along the y-axis max negative of max rotation time.deltaTime multiplied by pickup speed, right? And probably I have mistaken here the axis. Okay, this is here the mistake. So we have created some of the core features of our script, and we have to check out whether it is works or not, and then we will implement some of the further features like damping, something like that, right? So let's check it on the Unity editor. Now you can see that it is working fine, right? But when we have released the keys, it will not stop because we haven't implemented the feature of damping. So let's implement it. So we have to create some more variables, whether the left or right key is pressed or not, or up and down key is pressed or not. So let's get two variables. Bool is horizontal keys pressed, and then private bool is vertical keys pressed, right? And the first one will be responsible for the left and right keys, and the second one will be responsible for the up and down keys, right? So let's create the start function, private void start, and then we have to assign the initial values of these variables. Rotation speed along the y-axis must be 0, and rotation speed along the x-axis must be 0 also. And is horizontal keys are pressed equals to false, and is vertical keys are pressed equals to false, right? And if left arrow is pressed, then is horizontal key is pressed equals to true, and if the right arrow is pressed, then we have to also designate it as true. And then if the up arrow is pressed, then we have to assign it as the vertical keys is pressed, and if down arrow is pressed, then we have to also assign the vertical keys pressed. At the beginning of this frame, we have to assign these variables to their default values. So here we have to implement our damping effect. So if is vertical key is pressed, and this must not be pressed, right? So rotation speed along the y-axis equals to Mathf.Lerp from rotation speed along the y-axis to 0 time.deltaTime multiplied by damping speed. And if not is horizontal keys are pressed, that means we have released the horizontal keys. So rotation speed along the y-axis, along the x-axis equals to Mathf.Lerp rotation speed along the x-axis to 0 time damping speed. Right, now we are all set up here, and now let's check out into the Geometry editor. Okay, now you can see that we have a very nice rotation, and we can also adjust here the damping speed and the pickup speed. Like it is 10, and now you can see that it picks up the speed more fast. And we can also increase our speed to 360 degrees. Now you can see that our ball is rotating very fast. And this kind of motion is very important when you are implementing some ball-like behavior or the smooth rotations, right? Also, this behavior is just like the inertia. The ball have kind of inertia, and this is something like simulation of inertia. If you like this video, then make sure to subscribe my channel and hit the like button.